All right, so pick up where we were. We were looking at the left-hand side when we've got this k plus 1. So I've added an extra term. I've got all the terms I had before, and then I've added this extra term, which is the k plus 1 one. Now, this gives us the key to almost all of these types of questions. So what we do is we're going to say, but wait a minute, all of this stuff here is this thing here, and we said that equal to k squared. So we replace all the stuff up to that point with k squared, and then we've just got this one, and I'll just multiply this out as we go. That's going to be 2k plus 2 minus 1, which is 2k squared plus 2k plus 1. Okay, and we want to show that that's equal to our right-hand side when we've got an n equals k plus 1. Our right-hand side is n squared, so k plus 1 squared. And if I do that expansion, I get k times k is k squared, k times 1 is k, 1 times k is k, 1 times 1 is 1. And so we say that that is equal to our left-hand side, and we've proven this by induction. So just to go over again, the basic idea is we show it for the lowest number, in this case 1. Looking here, 1 equals 1 squared. And then we do this funky thing where we assume that if it works for this, then it will work for that. So if it works for n equals k, so we're just doing the same thing but replacing it with k's, then it's going to work for this n equals k plus 1. So we write out one of the sides usually with this k plus 1, work out where the bit we're assuming is, substitute it out, and then show that it all equals up. So I'm going to do another example here. It's the same idea, just a little bit more tricky. So we've got this 7 to the power of n minus 4. We're told we want to prove that it's divisible by 3. So first we're going to check for 1. So step 1, check for n equals 1. Well, that's going to be 7 minus 4. 7 minus 4 is 3. Tick, that is divisible by 3. So part 2 is assume for n equals k. So I've got 7 to the k minus 4 equals, now divisible by 3, I'm just going to say it's 3 times something, 3 times a. Okay? Now, we want to now look at left-hand side when I've got this k plus 1, n equals k plus 1. We've got 7, k plus 1 minus 4 equals, and we don't know what it equals. But we've got to try to find how to pull this stuff out of this. Can I find a 7k minus 4? Well, it's a bit awkward because I've got this plus 1. So what we're going to do here is I'm going to use our exponential laws, power laws. We're going to say, well, that's 7 to the 1 times 7 to the k. Now it's sort of looking more similar. I've got this annoying part here where I've got 7 times this, so I can't just directly pull it out. I have to do a little bit of funkiness. So what I'm going to do is effectively do plus a 7 times 4 and minus 7 times 4 in here. And then I'm going to factor in this bit. So I'm going to say that is 7 times 7k, and then I'm going to factor in this. 7 comes out with minus 4, and then on the outside I've got 4 plus 28. What's 4 plus 28? 4, so minus 4 plus 28 is 24. And then I do my substitution. This now is 7 times 3a, and this I could say is